There are several notable differences between the International Electrotechnical Commission, or IEC, standards and those established by Underwriters Laboratories, or UL, and the National Electrical Code, or NEC. These differences often stem from the IEC intention to serve as a global standard, accommodating the diverse electrical systems and regulations found in various countries, whereas UL and NEC are primarily focused on the specific conditions and safety concerns within the United States. A significant area of divergence lies in ground fault circuit interrupter, or GFCI, trip currents. The IEC standard specifies a trip current of 30 mA. This higher threshold is designed to minimize nuisance tripping in environments prone to transient ground faults, such as industrial facilities or construction sites where equipment may generate temporary leakage currents. In contrast, UL standards mandate trip currents ranging from 5 mA to 30 mA depending on the specific application. The NEC, adhering to a more stringent approach, sets a trip current of 5 mA for GFCI devices. The rationale behind these low trip currents is to provide enhanced protection against electrical shock, particularly in locations where individuals are more likely to be present, such as bathrooms and kitchens. This stricter requirement aims to reduce the risk of electrocution in residential and commercial settings where human contact with electrical hazards is more probable. Another key difference concerns hospital-grade requirements for receptacles and electrical equipment. The IEC standard does not include specific hospital-grade requirements. This absence is largely attributed to the IEC global scope, which recognizes that individual countries may have their own distinct hospital-grade regulations and practices tailored to their specific healthcare environments and safety standards. Conversely, UL and NEC mandate hospital-grade receptacles with specialized features designed to mitigate the risk of electrical shock in healthcare facilities. These features typically include firstly isolated grounding contacts, which provide a separate grounding path to minimize interference and leakage current. Secondly, tamper-resistant covers, which prevent the insertion of foreign objects into the receptacle. And thirdly, contact-making enclosures, which ensure a secure and reliable electrical connection. The inclusion of these features in UL and NEC standards reflects the heightened safety concerns within healthcare settings where patients may be particularly vulnerable to electrical hazards due to medical conditions or the use of sensitive medical equipment. Beyond GFCI trip currents and hospital-grade requirements, other notable differences exist between IEC, UL, and NEC standards. For instance, circuit breaker ratings differ in their specifications. IEC standards utilize amperes, or A, to denote the rated current of a circuit breaker, whereas NEC standards employ amperes continuous, or cont, which refers to the maximum current that a circuit breaker can carry continuously without exceeding its temperature limits. This distinction is important because it affects how circuit breakers are selected and applied in different electrical systems. Voltage levels also vary between IEC and NEC standards. IEC standards accommodate a broader range of voltage levels to suit the diverse electrical systems found worldwide. NEC standards, on the other hand, are primarily tailored to the voltage levels commonly used in the United States. This difference reflects the historical development and standardization of electrical systems in different regions. Furthermore, wiring methods differ in their permissibility under IEC and NEC standards. IEC standards may permit certain wiring methods that are not allowed by NEC standards. For example, IEC standards may allow the use of solid aluminum conductors in certain applications, whereas NEC standards restrict or prohibit their use due to concerns about corrosion and connection reliability. These differences in wiring methods reflect varying approaches to electrical safety and installation practices in different countries. The IEC standard's flexibility stems from its goal of creating a globally applicable framework that can be adapted to diverse electrical systems and regulatory environments. It seeks to balance safety considerations with practical concerns, such as minimizing nuisance tripping and accommodating various wiring methods. The differences between IEC standards and UL and NEC requirements underscore the distinct conditions and safety priorities in the United States, where UL and NEC standards are tailored to address specific electrical hazards and installation practices. These differences are not necessarily indicative of one standard being superior to another, but rather reflect the unique needs and circumstances of the regions they serve. Electrical engineers and technicians working in international settings must be aware of these differences and ensure that they comply with the relevant standards for the specific location and application. In summary, the IEC standard serves as a global framework, balancing safety with practical considerations, while UL and NEC standards cater to the specific conditions and safety concerns within the United States.